using HFACS to investigate rail accidents. Case study, Amagasaki rail crash, 2005. What is HFACS? HFACS stands for Human Factors Analysis and Classification System. Developed by the U.S. Navy to analyze aviation accidents, now widely used in rail, healthcare, and more. Focuses on understanding human and organizational errors. Organizes causal factors into 4 tiers: Unsafe Acts, Preconditions for Unsafe Acts, Unsafe Supervision, Organizational Influences. Applying HFACS in rail investigations identify unsafe acts, errors and violations by train operators or signalers. Analyze preconditions for unsafe acts: fatigue, poor communication, distractions, team dynamics. Examine unsafe supervision, inadequate training, planning, or oversight. Assess organizational influences, safety culture, resource management, operational pressures. Case study, Amagasaki rail crash, 2005. Date, April the 25th, 2005. Location, Amagasaki, Japan. Casualties, 107 fatalities, over 500 injuries. Cause, train derailed due to overspeeding on a curve. Operator was under pressure due to previous errors and tight schedules. Investigation revealed deeper organizational and supervisory issues. HFACS analysis, Amagasaki rail crash. Unsafe acts, operator exceeded speed limits. Preconditions, operator fatigue, high stress from disciplinary system. Unsafe supervision, inadequate handling of operators' prior errors. Organizational influences, culture of strict punctuality over safety, punitive error management. Benefits of HFACS in rail safety: provides structured framework for root cause analysis. Moves beyond blaming individuals to systemic issues. Identifies actionable improvements in training, supervision, and policy. Encourages continuous learning and safety culture enhancement. HFACS framework overview. Visual hierarchy explained. The framework is typically visualized as a top-down vertical stack, where each level influences the one below it. 1. Organizational influences. Top tier, strategic level. What it is: the broadest and most systemic factors that shape safety outcomes. These are long-term decisions, policies, and culture set by upper management or governing bodies. Key elements: resource management, budgeting, staffing levels, and allocation of safety-critical equipment or tools. Organizational climate, attitudes towards safety, communication culture, hierarchy, and morale. Organizational processes, formal and informal rules, standard operating procedures, SOPs, maintenance practices, and risk management protocols. Example, Amagasaki crash, a corporate culture that prioritized punctuality over safety and enforced punitive retraining policies that increased stress on drivers. 2. Unsafe supervision, second tier, managerial level. What it is: errors or deficiencies in how frontline staff are managed, trained, and supported. Key elements: inadequate supervision, poor or absent oversight, lack of mentoring or skill assessment. Planned inappropriate operations, assigning personnel to tasks beyond their capabilities or under unsafe conditions. Failure to correct known problems, ignoring repeated incidents or complaints. Supervisory violations, willfully disregarding safety policies or procedures. Example, Amagasaki crash. The train operator had previous infractions but was put under intense disciplinary scrutiny instead of being properly coached or supported. 3. Preconditions for unsafe acts, third tier, operational environment. What it is: factors that affect worker performance at the moment of action, including physical, psychological, and environmental conditions. Key elements: environmental factors, noise, heat, visibility, and system design. Condition of operators, fatigue, illness, stress, distraction, or lack of situational awareness. Personnel factors, communication issues, team dynamics, or inadequate training. Example: Amagasaki crash. The driver was under mental pressure, likely fatigued, and trying to make up for lost time, all impairing decision making. 4. Unsafe acts, bottom tier, frontline behavior. What it is: the immediate actions or omissions by operators that directly lead to an accident. Key elements: errors, skill-based, slips or lapses. Decision, misjudgments or poor choices. Perceptual, misinterpretations of the environment. Violations, routine, regularly accepted rule breaking. Exceptional, one-off breaches in extreme conditions. Example: Amagasaki crash. The train operator exceeded the speed limit on a curve to recover from a delay.